Welcome to Maths for All. I'm Aisling Flynn. This is the line 1.4 equation of a line. So we have already seen that the equation of the line can take the form of y equals mx plus c. Recall that m is the slope of the line and c is where the line cuts the y-axis. We call that the y-intercept. Given a line drawn on a graph, we can look at the line, we can find m and c, and we can write its equation. So the slope of each of these lines is given. Write the equation of each line in the form of y equals mx plus c. Okay, so let's look at the first one. M is 1, and c, where does it cut the y-axis? At 1. So we can simply write y equals 1 times x, so that's mx plus c, or more simply y equals x plus 1. Alright, let's look at number 2. Here we have slope is 1/4, okay, and the y-intercept crosses the y-axis at 2 here. So y equals mx plus c, y equals 1/4 times x plus 2. Okay. And finally we have slope of 2 for the last one and intercept of -2. So we would write y equals 2 times x, that's mx, plus c. And in this case c is negative, it's -2. So that's our third line there. So we're familiar with that already. Line equations can be presented in many ways. We are familiar with y equals mx plus c. We saw that on the previous slide. We're taking the line y equals 2x plus 3 and rearranging it. And we could also write it as, so in a moment we'll see what that is. But what happens if I was to put all of the terms of the equation of the line onto the same side of the equals? Okay, so in a moment we'll see the result of this. So I'm going to take y from the left hand side, which means you must do the same with the right hand side, and we'll be left with 0 on one side and the other stuff on the other side. So this is what it results in. We have 2x minus y plus 3 together on one side, and the other side is equal to 0. So it's just moving things around. It's the same thing though. Alright, and this is the form ax plus by plus c equals 0, and in some questions in your exams you're asked to present the equation of the line in this form. So it just means to move everything to one side and leave the other side empty, equals to 0. Okay, so let's work with this form for a little bit. So here's an example question. Draw the line 4x minus 2y minus 2 equal to 0 on the coordinate plane. Okay, so it's not so easy starting like this as it is y equals mx plus c. You can't see things immediately. We're going to use it and we're going to use it to find some points. Okay, we need at least 2 points to draw a line. So a from and a to, and then we can draw a line. Okay, so what 2 points will we find? We're going to find where the line crosses the y-axis and where the line crosses the x-axis. Okay, if you get those 2 points, then you can join them up with a ruler and draw the line. So we're going to do that on the next slide. So here's our equation. Draw this line on the coordinate plane. Coordinate refers to x's and y's. Okay, so to find where the line cuts the x-axis, all the points on the x-axis have a y value of 0. Okay, so on that horizontal x-axis you'll have 1, 0, 2, 0, 3, 0, 4, 0, minus 1, 0, and so on. They all have a y value equal to 0, okay, because the points are not up any distance and they're not down, okay. So what we do now is we take the equation of the line and we put 0 in here instead of the y. So we have 4x minus 2 times 0 minus 2 equals 0. When you multiply anything by 0, it becomes 0, so that disappears, and we have 4x minus 2 equals 0, and now we're going to solve for x. We'll add 2 to both sides, if you want to write that in, and we get 4x equals plus 2. Divide both sides by 4, and we get x equals 2 over 4, if it was written one on top of the other, or a half, okay, or 1.5 or 0.5. all right, so we're going to repeat that for where the line cuts the y-axis. So the y-axis is the vertical line of a graph, and every point along here is not left or right, okay, so it has x value 0. So what do? We take our equation of the line, and this time we replace x with 0. And multiplying anything by 0, 4 times 0 is 0. So we have minus 2y minus 2 equals 0. So on the next line what we've done is we've added 2 to both sides. We get minus 2y equals 2, and then we'll divide both sides by minus 2. And we get 2 over minus 2, which is minus 1. Okay. So mark these points on the graph and complete the line. So before we go to marking, the 2 points we've gotten for the x-axis, y value was 0 and the x value was 0.5. That's x comma y. And from the second one we had x value 0 and the corresponding y is minus 1. So here we'll see those points. So this point here on the graph is half, 0.5 comma 0, and this point here is 0 minus 1. And when you have the 2 points, you can put a ruler down and you can draw your line straight through them, and this here is the line 4x minus 2y minus 2 equal to 0. Okay. Writing the equation of a line. When you cannot immediately write the equation of a line as y equals mx plus c, we use the equation of the line formula. For this, you need 2 pieces of information. The first one is the slope m, and the second one is any point on the line, and we use x1, y1 for that. And this is the equation of a line formula. Y minus y1 equals m times x minus x1, and it is available in the formula and tables books. We'll look at that in a minute. So first we're going to put it into action and try this question. Find the equation of the line passing through minus 3, 4 and 2, minus 6. So first of all we have to find that first piece of information, the slope. And to do that we use our slope formula, which we're familiar with. Okay, to use the slope formula we need 2 points, which we have, and we'll just label those 2 points. x1, y1 is the first point and x2, y2 is the second point. We'll substitute those values into the formula. So here we have that. So we have y2 minus y1 over x2 minus x1, and I always use brackets when one of my values is a negative value. Okay, so looking at the top line, you have -6 minus 4 gives -10, and underneath you have 2 minus -3, which equates to 2 plus 3, and 2 plus 3 is 5, and so -10 divided by +5 is -2, so our slope is -2. So that's the first piece of information. The second piece of information is to have a point, which we do. We have 2 of them, and we can choose either or, whichever one we like. Okay, we'll use the first one probably, and we're going to use our new formula, the equation of the line formula, y minus y1 equals m times x minus x1, and let's substitute the correct values into that. So regular y stays, so it's y minus y1 is 4 from here, up above here. That's our y1. So y minus y1 equals, now our slope we found out was -2, so that goes in instead of m, times x minus -3, which becomes a plus. Okay, skip that line there because I think we're short on space. Okay, so minus minus, take care when you have negatives, becomes a plus. Now what remains is for us to multiply out that bracket. So we get y minus 4 equals -2x minus 6. Okay, now we're finished here essentially. We have an equation, it describes a line, but we might tidy it up and present it in a way that we're used to. Okay, so one way we saw is to move everything to one side. So what we've done here is we've added 2x to both sides, left and right, and we've added 6 to both sides, left and right, and so you're left with nothing or 0 on the right hand side. And this is what we have on the left hand side, 2x plus y minus 4 plus 6, and the numbers we can combine there. We get 2x plus y plus 2 equals 0, and there's the equation of our line. Okay, here's the page in the formula and tables book. You'd be looking for coordinate geometry, you'd be looking for the line, and you'd be looking for the word equation, so not slope, not length, not midpoint, but equation of PQ. And here we see the formula for inputting our values, and here you see the other one that we're familiar with, y equals mx plus c. Now we're going to look at some horizontal and vertical lines and their equations, so the equations that describe them. Okay, so here's a red line and it's horizontal. Here's a blue line which is vertical. Let's look at the red line first. For the horizontal red line, every point on that line has y value of 3. Okay, so let's look at some points along there. So this point here has x value 0, it's 0, 3. This line over here is 3, 3. And this point back here is -4 for the x value and 3 for the y value. So they all have y values of 3. And that would continue if we continued the line forever in both directions. Okay, so the equation that describes this red line, which is horizontal, is simply y equals 3. That's the y equals 3 line, where every point all along it has y value 3. Okay, and similarly for the vertical blue line, every point on that line has an x value of -2. Okay, so let's just examine some of them there. So this point up here would be -2, 7. We'll move on down. This one here is -2, 5. We can go right down to -2, 1, -2, 0, and we can go below the x-axis. That one there would be -2, -3. So every point, and even between the whole numbers, would be the case. Say if I took this one, be minus 2 minus 4.5, say. Okay, so every point up and down along that blue line has an x value of minus 2. So quite simply, we describe the line as being the x equals minus 2 line. Okay, so very simply, for horizontal and vertical, what's common for all the points on that line. Now, another type of question you could be asked is to check, does a point belong to a line? And a point belongs to a line or is part of the line if it makes the equation of the line true. If when you put in the values you get left equals right. If it makes it true, the point is on the line. If it doesn't work and it's not true, then the point is not on the line. So if a point is on a line, the coordinates of the point should make the equation true. To verify a point is on a line, we substitute the x and y values into the equation and we show that left equals right. Okay, so if the word verify is used, it means show that it is true. So we expect left equals right. So number 1, we're asked to verify that the point 2, 3 is on the line 2x minus 3y plus 5 equals 0. So what we're going to do is we're going to take the values from our point, our x, y, and we're going to replace the x and the y in the equation with them. And if this point 2, 3 belongs to the line, well, then it is described by the line and we should get 0 equals 0. Okay, left equals right. So let's try that. So substituting, we get 2 times 2 minus 3 times 3 plus 5 equals 0. And multiplying, we get 4 minus 9 plus 5 equals 0. And that of course gives us 9 minus 9. We get 0 equals 0. So what can we say? And you should give a conclusion each time. I'm going to say, well, that's right. So 2, 3 is on the line because 0 equals 0. Okay, second question. If the point 1, k is on the line 2x minus 3y plus 7 equals 0, find the value of k. Okay, now students, when they're given letters instead of numbers, tend to get confused, but you shouldn't. Okay, we're told it is on the line, so it's part of the line. So we know that if we put an x value and a y value from this point, which is on the line, into our equation, we are supposed to get 0 equals 0. Left equals right. So just because you have a letter doesn't mean you shouldn't follow the same procedure as you did in question 1. So let's see. We're going to replace x with 1 and y with k. Okay. So 2 times 1 minus 3 times k plus 7 equals 0. Multiplying, we get 2 minus 3k plus 7 equals 0. Because it had a negative, I chose to add 3k to both sides. Now you can take a piece of paper and do these workings yourself. You're left with 2 plus 7 on the left. So we get 9 equals 3k. I'm going to solve for k, which will be, when you divide both sides by 3, you'll get 1k equals 3. Okay, so just because there's letters involved doesn't mean you shouldn't follow the same kind of steps as you did in question 1. Now it's time for you to try some work around that. You can try the quiz, equation of a line, and the written exercises.